Have you ever wondered, what is it that travels through the universe, unhindered by matter, almost as fast as light itself? This isn't science fiction, it's the reality of our universe, a reality that is as mysterious as it is fascinating. Allow me to introduce you to neutrinos, the cosmic wanderers that are everywhere around us, yet remain largely unknown to us. Neutrinos, the ghost particles of the universe, are one of the most abundant particles in existence. They are so tiny and so weakly interacting that they can pass through light years of solid steel without even flinching. Imagine a particle so elusive that it can journey from the heart of the sun to your morning cup of coffee without disturbing a single atom along the way. These tiny particles are born from the nuclear furnaces of stars, like our sun, where they are produced in vast quantities. Every second, countless neutrinos are ejected into space, embarking on a journey that might take them across galaxies, or straight through your living room. But their existence isn't limited to stellar origins. They are also the byproducts of radioactive decay, nuclear reactions, and even the cataclysmic events of the cosmos, like supernovae. When a star explodes, it doesn't just send out light and heat, it also sends out a colossal burst of neutrinos. These neutrinos, much like cosmic postcards, carry with them information about the event and the environment they originated from. Despite being everywhere, neutrinos are incredibly hard to study. Their elusive nature makes them difficult to catch, and their weak interaction with matter makes them even harder to detect. But every mystery presents an opportunity for discovery, and the enigma of neutrinos is no different. As we delve deeper, prepare to unravel the enigma of these elusive particles. In the vast cosmic theater, neutrinos play a role that is as mysterious as it is crucial. So, strap in for a journey to the very edge of our understanding, where we'll explore the fascinating world of these ghostly particles. Neutrinos, these ghostly particles, what are they exactly? Well, to put it simply, neutrinos are subatomic particles, meaning they're even smaller than atoms. Most things we interact with on a daily basis are made up of atoms, so you can imagine just how tiny these neutrinos are. But their size isn't the only thing that sets them apart. Unlike protons or electrons, neutrinos carry no charge. This means they don't have a positive or negative label attached to them. They're perfectly neutral, hence their name. Neutrinos, which translates to little neutral ones in Italian. Now, if you think that's fascinating, wait till you hear about their mass. Neutrinos have such a minuscule mass that for a long time scientists thought they were completely massless. It's only in recent years we've discovered they do have a tiny bit of mass, but it's so small it's almost negligible. And here's where things get really interesting. Because they're neutral and have very little mass, neutrinos don't interact with matter in the way that other particles do. Imagine walking through a wall as if it wasn't there. That's what life is like for a neutrino. They zip through the universe, passing through planets, stars, and even you and me, without disturbing a single thing. For every second that passes, trillions of these tiny particles are passing through your body. And yet, you don't feel a thing. They're everywhere, all the time, silently moving through the universe, unseen and unfelt. This elusive behavior makes neutrinos incredibly difficult to detect and study. But it's also what makes them so intriguing. Their ghostly presence challenges our understanding of the universe and the laws of physics. They're a testament to the fact that there's so much more to the universe than what meets the eye. These elusive entities leave us fascinated yet perplexed, fueling our curiosity. Why should we care about these ghostly particles that we can't even see or feel, you might ask? Good question. Despite their elusiveness, neutrinos play a crucial role in the grand theatrics of the cosmos. Neutrinos, these minute particles, are the universe's little messengers, carrying information from far corners of the universe. They are born in the heart of stars, during cataclysmic events like supernovas, and even in the Big Bang itself. Each of these events produces a unique fingerprint of neutrinos that zip through the universe, unaffected by magnetic fields or matter, carrying with them the secrets of their birthplace. Imagine you're an astronomer, and you want to know what's happening inside a distant star. You can't just drill a hole and take a peek. But what you can do is wait for the star to send its neutrinos your way. By studying these neutrinos, you can gain insights into the star's inner workings, its composition, and even its future fate. Neutrinos are also crucial in understanding the origins of our universe. The Big Bang theory suggests that the universe began as a hot, dense point nearly 14 billion years ago. This event should have created equal amounts of matter and antimatter. But here's the mystery. When matter and antimatter meet, they annihilate each other. So why is there so much matter left in the universe? Why are we here at all? The answer could lie in neutrinos. Some theories propose that neutrinos could have tipped the scales in favor of matter during the early moments of the universe. By studying neutrinos, we might just be able to unravel this cosmic conundrum. So while neutrinos might seem ghostly and elusive, they hold the potential to answer some of the deepest questions about our universe. Every neutrino detected tells a story of the cosmos waiting to be heard. How can we possibly detect something that hardly interacts with anything? This question has stumped physicists for years, but as they say, where there's a will, there's a way. Detecting neutrinos is no walk in the park. These tiny particles zip through the universe almost undisturbed, barely interacting with matter. That's because they only interact via the weak nuclear force and gravity, which are, well, weak. So to spot them, we can't just rely on traditional methods. We need to get creative. Picture giant detectors, colossal structures filled with water or other substances, waiting patiently for a neutrino to pass by. These detectors, such as the Super Kamiokande in Japan or the Ice Cube Neutrino Observatory in Antarctica, are not your average laboratories. Their size and the materials they contain are crucial to their function. Inside these detectors, neutrinos can occasionally interact with the atoms of the substance, causing a tiny flash of light. This light, known as Cherenkov radiation, can then be picked up by sensitive photomultiplier tubes lining the walls of the detector. The intensity and direction of the light can even help us figure out the type and energy of the neutrino that caused it. But even with these enormous detectors, we catch only a handful of neutrinos. Out of the trillions that pass through the detector each day, maybe one or two will interact and be detected. It's like trying to catch a grain of sand in a hurricane with a butterfly net. It requires patience, precision, and a whole lot of luck. Yet despite the challenges, we have made significant strides in neutrino detection. These elusive particles, once thought to be undetectable, are now within our scientific grasp. We've caught a glimpse of these cosmic wanderers, and that glimpse has opened up new avenues of understanding about our universe. In the pursuit of the unseen, we have devised ingenious methods to capture the uncapturable. Neutrino detection, like neutrinos themselves, is a testament to the power of curiosity and the relentless human drive to uncover the mysteries of the universe. Let's recap the fascinating journey we've embarked on today. We've ventured into the depths of the universe, all from the comfort of our own planet, and we've done so by exploring the enigmatic neutrinos, those elusive wanderers of the cosmos. We started by defining neutrinos. These subatomic particles, born in the fiery hearts of stars, are fascinatingly neutral in charge and incredibly light in mass. Unlike their more interactive cousins, neutrinos barely interact with matter, making them ghost-like travelers that zip through space, through planets, even through us, mostly unhindered. Next, we delved into the sheer importance of neutrinos. Despite their elusive nature, neutrinos hold critical keys to astronomical puzzles. They play a pivotal role in the workings of the universe, from the nuclear reactions in stars to the very balance of matter itself. Their ghostly existence provides us with a unique window into cosmic events that other particles can't offer, allowing us to observe and understand the universe in a whole new light. From there, we discussed the complex and fascinating world of neutrino detection. Despite their elusive nature, scientists have developed ingenious ways to detect these elusive particles. Using massive detectors nestled deep underground or beneath the ocean, we can capture the rare interactions of neutrinos with matter, enabling us to study their properties and origins. This is no small feat, given the billions of neutrinos that pass through just a square inch of space every second, largely unnoticed. We also emphasize the ongoing research in the field. Every discovery, every detected neutrino, brings us one step closer to understanding the universe. From the deepest mines to the farthest space observatories, scientists are relentlessly searching for these elusive particles, hoping to unlock more of their secrets. As we continue to unravel the mysteries of neutrinos, we inch closer to understanding the universe, one particle at a time.